Nobody wants to.
If
Okay,
I can photocopy notes for the...
We are now on. Okay, factoring. Now this was yesterday's lesson.
Yes.
Okay, in yesterday's lesson we were talking about imaginary factors. So on this one it says to factor. Can we factor? Normally, can we just look at that and say, I know how to factor that?
No.
No. So we're going to have to say, okay, it's probably got imaginary solutions, especially since it was from yesterday's lesson. So we're going to have to use our what? Quadratic formula, okay, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a to find the roots, and then we're going to have to go back and build the factors, right? So here we go. Negative b is what?
2.
Okay, so negative 2 plus or minus the square root of
4.
4 minus 4 times 1 times negative 5. Okay, over 2a. And that 2 is going to be just 2. All right, so now, is it imaginary?
Yes.
That's a minus and that's a minus.
Oh.
So it's not imaginary, it's just not factorable. Okay, so we're going to end up with 20 plus 4 or 24. So negative 2 plus or minus the square root of 24 over 2. 24, we can break a perfect square out of that and make this what? Negative 2 plus or minus the square root of what? Okay, 6 and what goes here? 2 square root of 6 over 2. Can I divide everything by 2?
Yes.
Okay, so I have negative 1 plus or minus the square root of 6. Okay, now, guys, somebody come up here before I have to assign somebody to come up here. Okay, so this needs to stay. Thank you. All right, so now that I've got these, how am I going to make the factors? How am I going to make the factors?
X equals minus parentheses minus 1 plus or minus square root of 6.
Okay, now this is the x, right? So x is, so you're saying negative 1 plus the square root of 6. X is negative 1 minus the square root of 6. Is that what you're saying? Okay, so we have two x's. How do we make the factors? We're supposed to factor this thing. We have the x's. We have the roots. How do we factor?
X minus root.
X minus root. Okay, so now we're going to have what? Let's put the factors right here. X minus negative 1 plus the square root of 6. X minus negative 1 minus the square root of 6. We simplify that to get what? X plus 1 minus square root of 6. X plus 1 plus the square root of 6. And those would be our two factors. Okay, now, if I took those two factors and multiplied them together, I would get the equation. All right? So let's go on to today's lesson, which is 47, and we're talking about sinusoidal translations. Okay? So I'm just keeping it active by occasionally touching the pad there. All right? So, sinusoidal translations. Now, look at this. This, we talked about sinusoids. All right? So what sinusoid does that one look like? Robbie, what sinusoid does that look like? Remember, we call them both sinusoidals, whether they're cosines or sines.
Cosine?
Why would you say that looks like a cosine? Does it have a nose like a cosine, or eyes like a cosine, or hair like a cosine? Okay, what would you say you would recognize about a cosine that makes that look like a cosine? Yes?
Lows at 0.
Is that a low at 0 or is that a 0 at 0? Which function has a 0 at 0?
Tangent.
Sine, thank you.
Oh!
The sine has a 0 at 0. Okay?
Got you.
And the sine comes back to a 0 at 180, doesn't it? Think of your unit circle. Here's your unit circle. Your sine is the height of your unit circle. Your sine is 0 at 0. your sine goes back to 0 at 180. 0. At 180, it's 0 again. Guess what the sine does again at 360? It's 0 again. So your sine is going to 0, 0, 0 at 0, 180, and 360. It's doing the same thing on the other side. Okay? Now, so since we've established this is a sine of theta, okay, which it is, something's happened. Look at this row here. Okay, we've gotten 4, 6, 2. What's normally there?
0.
0, 1, -1, right? Isn't that what was there on our basic? Like you'd say, that's my parent sinusoid. Okay, so this one's gone to 4. What has happened? We've translated the baseline of this function up to 4. We've made a shift, a vertical shift. That's what we're talking about today. So where is the vertical shift to? We've shifted to 4. Okay, so could we put a +4?
Yes.
Right, outside the function. Now your book puts the +4 in the front. Does it make any difference?
No.
No. Okay, so +4. Why is +4? That lifts up that baseline, and then how high does it go above that? 2, and then down 2. What was that? The amplitude of the function. How high or how low that it goes. So we're going to put +2. Why did I use a +2 instead of a -2? What would a -2 do to the function?
It's reverse it.
It would flip it all the way over, wouldn't it? And this is a positive sine function. Why? The sine goes up and then it comes down. When you look at the sine as the height, the sine goes up and then it comes down. So this should be the +4 + 2 sine theta is the equation for this sinusoid. Okay, let's look at this one down here. Good. All right, now on this one, we'll go ahead and erase this stuff down here because this is from the last problem. Okay, now look at this sinusoid. I didn't quite get finished. That's -270. All right, and then this one right here, this high, is -360. Okay, now we're done. Look at this graph. You say, what does it look like?
Cosine.
It looks like a cosine, okay? What features make it look like a cosine?
0 at 90.
Okay, it has a 0 at 90, and our cosine, remember, is our left-right motion, and our cosine is a 0 at 90. Our cosine is also a 0 at 270. Is that looking right? It's a 0 at 90 and a 0 at 270.
Yeah.
Our cosine at 0 is 1. Okay, and that's looking good here. Okay, guys, please. So now, what is this going to be? You guys can stand up, move somewhere else, but that's a little awkward. Okay, so now we've got, since we've decided that this is a cosine of theta, okay, what can we do? We need to find, what is the baseline? Now in this one, the baseline's not labeled. Would the baseline be halfway in between though?
Yes.
Okay, so if I have -5 to -6, what kind of distance is that? My high is -5, my low is -11. What would be my distance?
6.
6, okay. So I'm going to come down 3, halfway between the 6, come down 3 from the -5, and what will I have?
-8.
-8 will be that center line. So even if that center line is not given to you, you could find it because it's going to be halfway in between your high and your lows. Okay, so now if my baseline is -8, I'm going to have a -8 plus, now it is a plus cosine, right?
Yes.
It's not flipped over like an inverted cosine. So now I have to say, okay, what's going to be that amplitude? Baseline plus or minus what?
+3.
+3. Okay, and it is going to be positive. So I'll put my little y equals there, and that'll be that equation. That's not hard at all, is it? Okay, let's go look over here at this last one on here. Okay, now this one is the same type of thing. We're saying, has this been, what type of function would you give this? Okay, Close. It is a
Sine.
sign.
It's a
What is it?
sign,
What kind of sign?
Negative. 'cause it
Negative
goes down.
sign because it's going down first. Okay. Notice that we haven't started messing with the period of the function yet. We're going to do that later. Right now we're working with vertical shifts. All right. So this is an upside down sine function. So we'll say it's a negative sine theta. Okay. And it has got a baseline of what? The baseline's not labeled here.
Negative
20
10.
to the center and then 20.
Okay, so we've got a negative 6. I don't know why that says 60. I think it's just a negative 6. A negative 6.
No, we
Negative
agree,
60
yes,
is
it is.
negative.
Okay, negative 6 and negative 14. So it's going to be what for the center line?
Negative 10.
Okay, that's a step. That's an 8 step right there. So we're going to cut it in half. 4 steps down is going to be a negative 10. So that center is negative 10. So we're going to put a negative 10 out here as the baseline. We shifted the whole function down 10 steps. And now, what is that distance?
4.
4. Okay, so it's going to be, since we already decided it was a minus sine function, it's going to be a minus 4. We put the amplitude in front of the sine. And doesn't this do the same thing that it did with our parabolas? Okay, once you learn how to transform these functions, it's the same for all the functions. Okay, this is moving the baseline of the function, and this one, I think you lost it. Yeah. And this one is, I think it.
Find out.
Okay, and then this one is stretching the function. Okay, it's stretching the function this way, that amplitude. All right,